We generally assume that the objects around us, the table, the phone, our own limbs, are solid. When you touch a wall, it stops your hand. That resistance creates certainty. You believe there is a there. It's a reasonable assumption, based on the information your senses provide. It is also structurally incorrect. If you look at an atom, you've probably been taught the Bohr model, a dense nucleus in the center with electrons orbiting like planets. It's a useful lie, a visual simplification for something the brain doesn't naturally understand. In reality, the scale is far more empty. If an atom were expanded to the size of a professional football stadium, the nucleus would be a small marble sitting on the 50-yard line. The electrons would resemble tiny gnats, drifting near the highest rows of the stands. Everything in between, almost the entire stadium, is empty space. Mathematically, an atom is 99.9999999% nothing. If you remove that internal emptiness from every human current, the entire human race would compress into a volume no larger than a single sugar cube. It would still weigh 5 billion tons. So the question becomes, why don't we fall through the floor? If atoms are mostly nothing and we are made of atoms, then the solid world should not feel solid at all. The reason you don't pass through your chair is not because stuff collides with stuff. It's because of the Pauli exclusion principle. A rule in quantum mechanics stating that two identical fermions, in this case electrons, cannot occupy the same quantum state at the same time. Electrons form shells around the nucleus. They are not tiny balls of matter. They are probability clouds, carrying negative charge. When you sit down, the electrons in your body are pushed toward the electrons in the chair. Because of the Pauli exclusion principle, and because identical electric charges repel one another, those electron clouds refuse to overlap. What you experience as touch is actually electromagnetic repulsion. You have never truly touched anything in your life. You are hovering an immeasurably small distance above every surface you encounter. Solidity is not contact, it is resistance. If we removed the empty space, we would be forcing these electrons to abandon their shells and collapse into the nucleus. We would be breaking the very mechanism that gives the universe its volume. To understand what remains when the space is gone, we have to look at what that space actually consists of. We call it empty, but that is a linguistic failure. In physics, there is no such thing as a true vacuum. According to quantum field theory, the universe is composed of various fields that permeate all of space: the electromagnetic field, the electron field, the Higgs field, and others. What we call particles are simply localized excitations or ripples in these fields. Even in a perfect vacuum, these fields are still there, fluctuating at a baseline level known as zero-point energy. When we talk about removing the space in an atom, we are specifically talking about overcoming the forces that keep the nucleus and the electrons apart. If you apply enough pressure, the kind found in the core of a collapsing star, the electrons are forced into the protons. This is a specific mechanism called electron capture. The negative electron and the positive proton cancel each other out, turning into a neutron and releasing a neutrino. What you are left with is a neutron star. In this state, the empty space is gone. The atoms have collapsed. Matter becomes so dense that a teaspoon of it would weigh about 1 billion tons. But even here, there is a secondary mechanism preventing total collapse: neutron degeneracy pressure. This is the same Pauli exclusion principle, but applied to neutrons. They refuse to be in the same place, and that refusal creates a physical pressure that can hold up the weight of an entire star. However, even these neutrons aren't solid. They are made of quarks, and here is where the concept of mass becomes even more detached from our intuition. If you add up the mass of the 3 quarks that make up a proton or a neutron, you only get about 1% of the particle's total mass. The remaining 99% of the mass comes from the binding energy of the strong nuclear force, the energy required to hold the quarks together via particles called gluons. Mass, therefore, is not an amount of matter. Mass is a measure of the energy trapped within these fields. If you removed the space and the energy, there would be nothing left at all. The implication is that the universe is not a collection of objects moving through a void. The universe is a void that has been textured by energy. Our perception of things is a byproduct of how our biological systems interact with these fields. We evolved to perceive a world of solid blocks because that is the most efficient way to navigate the macroscopic environment. It is helpful to see a wall as a solid barrier rather than a localized area of high electromagnetic repulsion. But if we look at the math, the stuff is a footnote. The volume of the entire observable universe, if stripped of its internal atomic space, would compress down to a sphere roughly the size of a few city blocks. All the galaxies, stars, and planets we see are essentially a light dusting of energy spread across a vacuum that is trying to remain empty. We are not solid beings living in a world of solid things. We are ghosts of energy, kept at a distance from one another by the stubbornness of quantum states. We are an arrangement of forces that have reached a temporary agreement to occupy a specific amount of volume. If you removed all the empty space in the universe, the result would fit inside a small corner of a human city. There would be no light, no chemistry, and no observers. The universe is not made of matter. It is made of the space between it and the energy required to keep that space open. Once you remove the void, you realize that the void was the only thing that was actually there.